Hello, welcome to lesson and assignment 7 for the Arduino Starter Kit in Electronics. Today we're going to do the usual stuff. We're going to read, watch the video, the supplemental video, including the video I'm doing here, the extra one. And this is the usual routine of things. Now we're starting to get into a bit of a groove, and some of these projects move pretty quick, so you should be comfortable at this point with kind of knowing the flow, but never, please, if I tell you to watch a supplemental video, take the time and watch it. You're going to have time. If I tell you to read the booklet, actually read the booklet. Don't rush through it. You're only hurting yourself. You're going to be bored. You're going to have extra time at the end. You're going to, I'm done. Well, yeah, theoretically, you could just wire everything and code it and not understand a thing. If I tell you to read, please read the booklet. If I ask you to watch an extra video, please watch the extra video. It's helping you. You're going to be much more comfortable. And then we'll build the project, upload it. Now, this is the first project in a while where there's a real problem. Some people I've read online said it was a problem with the book, a problem with the wiring, a problem with the board. I have found a couple different problems with this project, but I've also had students who upload the code, get a board, wire it, and it works perfect. That should probably be most of you, but there's a couple problems here. So let's just look, watch the video, read the booklet, please read, wire the board and submit a picture, verify the code and submit a picture of it verified, share the working keyboard, submit it however we're submitting things, if we're doing video or conferencing or seeing in person, however we are submitting live things, because it's not just pictures of lights anymore, it's sounds and different kind of effects. So share the work with me however you do, and do questions 1 to 7. Let's take a look, or do the questions for project 7, my bad. Let's look at what the questions are. What is a resistance ladder? Why is it useful? How does it work? That'll be in the book. What is each button connected to? What range of sounds are you producing? What is an array? How is the if function used in this project? How could you modify the keys to make even more sounds? And what are some of the limitations of the keyboard we made? So those are the questions you'll be looking at. You can find most of those in the book or doing a little bit of common sense application and digging around. So let's take a look at the project. Now, yes, we are doing something called a resistance ladder, right? Well, here we go. Let's go back here, right? So yes, and this is where the concept of a resistance ladder will be. I'm scared to move this because it's very sensitive, this project. Now, what that means is we put a series of resistors at the top, the first button we push, and in the video that I tell you to watch, the supplemental one, the girl in it explains it very well, so watch that as well. But the first button, there's no resistance, so it will send a full signal of 1023 to our analog in, and we can tell it to make sounds based on, if you read 1023, produce this sound out of one of your digital pins. If we push the next button, it's got a little bit of a resistance on it, right? The next one here has a little bit of resistance, just a small amount, 220, I believe. Now you've got to make sure, take a good look at the resistors I'm using there, right? Take a good look. You might want to pause the video. You might want to go back and make sure you got the right ones. Remember, you can find the proper resistors at the end of project 2, right there. It'll always tell you. And you can always look here. There will be a 220 resistor, so it'll be a little less than 223. I believe in our code we say anything above 990 counts as this button being pushed. And then we say anything over 550, I think, counts, and anything under 10 counts, because we put a slightly bigger resistor on this one, so it will restrict the flow a little bit more, and a very big resistor on the last one, which will really restrict the flow and barely make any signal coming out. So basically what we've written is that this analog pin, if it senses nothing, full 1023, we know that the top button was pushed. I don't have a button there, I'll explain that right away. If we sense almost 1023, we know it's this one because it's going through a light resistance. 550, we've cut about half of the power. And then if barely anything is coming through, we've pressed this button. And we write a code that corresponds to that. We're making a ladder of resistors. But notice they're all connected in series right to ground. Every single one of these buttons is connected to ground through a small resistor at the end as well. Now, that's a resistance ladder. That's the key concept of this one. Sorry about that. I'll turn that back on. I will only give you one thing to work on here for troubleshooting. You can learn about an array, but honestly, the arrays aren't something we do too much in the rest of this class. But you'll still have to answer the question, and the stuff about arrays is here on page 82 and 83. And notice, first of all, this isn't actually part of the code. It's written like it is. This is where the code starts on line 1, right? So this is more of an example of how an array would work. You can read up on that a bit. We don't use arrays much more, but it's something good to know. Please define it and look it up and understand it. But what I want to show you is that's a problem people have. But the other real problem is, honestly, some of these boards are a little bit sketchy. They might have some strips that have been used a lot more than other strips. Notice that most of our projects use this side of the board, so this side of the board might go a little bit faster. It might be a little bit worn out. Also, I'm not going to lie, the buttons that we get included with this kit are not that great, right? So look what in theory is supposed to happen is there'd be a button here, right? And I can put this button here, and maybe I'll get lucky, right? And I can't quite, sometimes you have to angle your buttons. Some buttons, I would say half of the buttons are sketchy. So if you're working with someone else or someone else is nearby, you can wipe off their buttons, clean them, put them on your board if they know they have a working button. And then when you're done making your board work, share the buttons, give it to another person, maybe wipe them down, and you can do that. Or you can kind of do what I did, which is a little sketchy, but we'll show you some cool stuff because this is a great troubleshooting kind of way of looking at it. Remember, we've got that analog in right here, and we can read what is coming to it at all times, and we can do that. We can use that to find out what's happening in our board. If we can't see the flow of electricity with our eyes, we can read what's coming into that analog in and do a lot of troubleshooting, which I think is really cool. So the problem I was having, and I've got the monitor on right now, I'm reading, it's 0 because nothing's pushed, right? Now, in our code, I believe our buttons, we set different values for different buttons being pushed, a different amount of current. Let me find that for you here, right? So we said, if you get a signal of 1023, put the first note 0, the lowest note. Well, first of all, when I was putting this button in and really jamming it, I was getting it was a loose connection and it will do the crackling and it's sending, I wish I could do it right now. Let's see, maybe I can replicate that with this wire because that's all a button is a connection. So I'm just inserting a wire. Let's see. Yeah, right? And you can see here, 1016, 976, 1015, 1011. As I do it, it's kind of like, it's not quite 1023. So somewhere in all of these wires, there's maybe a little bit of a weak signal. So it's not giving a full 1023. It's like 1016, 1017, very close to 1023. But there is a problem either in my power wire or something else connecting here. So I had to change the code. I changed it. Before it said if the key value equals 1023, which means absolute full power, play the first note. But I'm never quite getting absolute full power. So I have to say, you know what, anything over, I decided, because I read my values, anything over 1014, we're going to count as the first note. So I can actually make that first note play if I get rid of my garbage switch, which if I jam it in there and wire it, I can make it work sometimes, but I can make a good value with this, right? So let's try that. Right, I'm getting 1018, 1019. So even with a wire instead of a button, I'm still not quite getting 100%, which leads me to think that I'm getting a little bit of low voltage coming maybe out of my computer, or maybe this wire isn't quite right. I'm not getting exactly the voltage I need, but I can prove that it works. So you can see it's a little weak. So I changed my code. I'll take that out. I changed my code instead of being equals 1023 here. I said greater than 10 14. I made up a close number because the next button is very little margin of error here. If you look, the next button says anything from 990, right? Anything over 990. And if I push the next button, 996. So I only have between 996 and 1014 of a margin of error. So I have to be very careful with my code. But I can always read and see what each button is doing, which is really cool. So if I push this one, I'm getting about 995, 996 reading to that analog in. So in my code, it tells it to put out a slightly different note. Listen to those notes. They're different, right? This is the lowest one. And then here, 509, and I'm barely getting any. I'm getting 7 and 8 out of 1023 on there, which if you look at the code, anything over 990, right, to 1010 will give us the second note, 505 to 515 will give us the third note, and 5 to 10 will give us the last note. And that's how precise these resistors are. You've got to use the right resistors or you're going to get different values here as you push them. And of course, if you have a bummed switch, you might never get that to work, right? So I kind of made my own switch. So yeah, this is a frustrating project. I'm not going to lie. I don't have a great solution for it, but you could show that if you could prove that you're getting the key values when you go to monitor within the range that you've declared in your code, you should be in good shape. This is one that you might be doing a little bit of smacking your forehead going, what's wrong? But remember, you can always turn on the monitor when you're using those analog ins and see exactly what you're getting and see what's happening in your circuit. You might be getting low voltage from your computer, which means a little bit less than 1023. So I hope you enjoyed this project. That's the biggest troubleshooting with this one. And remember, with the piezo, please be careful with it. Please put it in gently, and you might have to wire it a little differently than the diagram as well. If you look at the diagram, it's like very close together. Well, guess what, buddy? These are on the diagram. It says here it's 2 apart, but in reality, the closest you're gonna get is about 4 apart. So you have to wire it a little bit wider apart, right? So there's another warning, is that the diagram up at the top is actually a little more spread out because of the piezos we have. Now, if you have one with wires, you can wire it exactly the same, but you'll have to kind of use common sense. Remember, always follow the flow of electricity in your mind and you will know where things should go, where you have to modify or tweak circuits. You can use other parts of the board, you can do other things. As long as you understand the flow, theoretically, there should be no problems. So let's look at what you need to do. I love this project. I loved it because it made me kind of upset when I was doing it, and then I learned, oh, wait, I can read it. I can go to the monitor and find exactly what's happening and tweak my code to make it work. Real troubleshooting. That's when you know you're getting comfortable with something, is when you could find errors and fix them on your own. Lesson 7, keyboard instrument. Watch the extra video. She does a great job of explaining a resistance ladder and a couple other things. Read the booklet, wire the board, submit a picture of your code verified. Share the working keyboard with me however we are sharing live things, and do questions for Project 7 and submit them, right? I hope you enjoyed this head scratcher of a project, and we will be working on an hourglass, I think, on the next project or very shortly. And it's a pretty fun one too, with a neat sensor. So we'll see you soon.